Good morning, all. So the previous meeting was ended due to some technical errors. Okay, so now in the previous video, we stopped at the roots of the water uses and the disposal. So the this figure shows that the different water routes, that how from the where the water is collected to how it will be transferred or migrated from the one location to another location, and as well at the end after the disposal point of view. Okay, so the groundwater, this is the raw water, the water treatment plant, rural areas, and the wastewater were collected in the urban area in the water distribution network, and the water treatment plant or the treatment processes are going to take further. And after that, the treated wastewater is runoff by the surface water systems. Okay, so there are some kind of the definitions which we are going to discuss. The first is raw water. Initially, water is abstracted from the river, lake, or a water table and has a certain quality. Whatever. So the raw water, it is initially abstracted from the river, lake, or water table, and has a certain quality. So it has a certain kind of impurities and the residues which are available, but it is acceptable in the acceptable limits. Okay, so this is called the raw water. The second is a treated water. After abstraction, water undergoes transformation during its treatment to be able to comply with its intended uses. So the raw wastewater, the water after being used undergoes a new transformation in its quality and become a liquid waste. So after the completion use of the water, the remaining amount of the water with the impurities and the waste, it's called the raw water, raw wastewater. The water after being used undergoes a new transformation in its quality and become a liquid waste. The next one is a treated wastewater. Aiming at removing its main pollutant, wastewater undergoes treatment before being discharged into the receiving body. Wastewater treatment is responsible for the new modification in the quality of the liquid. So the treated wastewater is the after the main pollutants or the removing the main pollutants or the hazardous pollutants in the raw wastewater. The wastewater are going to undergoes for the various uses, for not a drinking purposes but for the other purposes. So that is called the wastewater treatment is responsible for the new modification in the quality of the liquid. The next one is a storm water. Rainwater flows on the ground, incorporates some pollutants, and is collected at the storm water system before being discharged into the receiving body. So the receiving body, storm water, and the effluent from the wastewater treatment plant reach the receiving body, where water quality undergoes a new modification as a result of a dilution and the self purification mechanism. So the particular association between the water use and the quality requirement, like the domestic use, the required quality is free from chemical substance harmful to health, which are harmful to health, free from the organism harmful to health, low aggressive and hardness, aesthetically pleasant, low turbidity, color, taste, and odor, absence of the microorganism. So for the domestic supply or for the domestic use, the main quality of water is that it is having the least pollutants available in that particular water, so that it is useful for the drinking, bathing, and other kind of the domestic uses. The next one is the industrial supply. So water incorporated into the product like the food, drinks, and medicines. So when any industries which are associated with the food manufacturing, drink manufacturing, or the medicine manufacturing, so there are certain kind of the quality of the water are required, that are free from the chemical substance harmful to health, the free from organism harmful to health, and aesthetically pleasant. That same kind of the qualities which are required is the domestic supply. So so this kind of the water quality is required when we are talking about the food manufacturing industries. So when this kind of when the other kind of the industries that require the water which interact or enter the contact with the product, so there are the variety of the products which require the variety of the quality of water. So it is a variable with the products. Water that does not enter into the contact with the refrigerator, so like the refrigeration units and the boilers, so there are kind of the low hardness and low aggressiveness qualities are required for that particular matter. So when in any industries the water is not directly contact or with not directly incorporated with the products, so there are the certain kind of the water qualities are required that contains the low hardness and the low aggressiveness. The next is the irrigation purposes. So if we are talking about the horticulture products integrated raw ingested raw or with a skin, so that are free from the chemical substance which are harmful to health, free from the organisms and the non-excessive salinity. So when we use the water for the irrigation or for the horticulture, and the water which are directly gonna used with the irrigation agriculture as well as as well as the horticulture, so what so which are directly related to the skin or a raw skin, so this kind of the water qualities are required, the free from chemical substance which are harmful to health and non-excessive salinities and other. In the other plantation that are free from the chemical substance harmful to the soil and the plantation, and the non-excessive salinity. So the for the irrigation purpose is the excessive salinity is dangerous for that, because as we know that the excessive salts or excessive alkalines which are available in the soil are reduce the nutrients of the soil and have a destructive effect on the plantation. So the water quality which are going to take place for the irrigation purposes, so it should be non-excessive in the salinity. So animal water supply free from chemical substance, free from organism harmful, preservation of aquatic life variable with the environmental requirements of the aquatic species to be preserved, and the aquaculture, so animal breeding and the vegetable growing. So that kind of the various required qualities are required, like recreational leisure, that primary contact, direct contact with the liquid medium, bathing, swimming, water seeking, surfing and so on. So the free from the chemical substance, free from the organism harmful, low level of the suspended solids and oil and greases. So the secondary content, energy generation, transport, and the water dilution and the transport. So there are different kinds of the required quality of the water are going to take place. So the next one is a water pollution. So water pollution is the addition of the substance or energy from that directly or indirectly alter the nature of the water body in such a manner that negatively affects its legitimate use. So the water pollution, or we can define as that the change in the characteristic, the change in the characteristic of the raw water, which leads to change or alter the primary purpose of the water, or the primary characteristic of the water. It's called the water pollution. So the water pollution is the addition of the substance or energy forms that directly or indirectly alter the nature of the water body in such a manner that negatively affects its legitimate use. This definition is essentially practical and as a consequence potentially controversial because of the fact that it is associated with the pollution with a negative alteration and with water body uses, concepts that are attributed by the human beings. However, this practical view is important practically when analyzing the control measure for the pollution reduction. The particular table shows that the main pollutants and the sources together with the most representative effects effects in the main in details the main parameters which characterize the quality of the wastewater for the domestic sewage, then which is the main focus of this particular chapter, is that a suspended solid biodegradable organic matter, nutrients and the pathogenic organism. So when we are talking about the wastewater or the domestic wastewater, there are the certain kind of the parameters and the certain kind of the characteristic which are going to take place for the any modification or for the any interpretations, like the suspended solid biodegradable organic matter, nutrients and the pathogenic organism. The solution of the most of this problem, especially biodegradable organic matter and pathogens, has been reached in many developed regions, which are now concentrated of the removal of the nutrients and the micropollutants, together with the substantial attention to the pollution caused by the stormwater drainage. In the developing regions, the basic pollution problems still need to be dealt with and the whole array of the pollutants need to be tackled. However, because of the scarcity of the financial resources in this region, priority need to be set, and those the gross pollution of by organic matter and the contamination by the pathogens are likely to be deserved higher attention. Naturally, each region has its own specificities, and this need to be taken into account when the setting up the priorities. Also, from the table, it is seen that it is a very difficult to generalize industrial wastewater because of its variability from the process to process and from the industry to industry. So when we are talking about the domestic wastewater, we can easily distinguish that kind of the different pollutants which are available in that particular water, like the suspended solid and the organic matter. But when we are talking about the industrial wastewater, so it is very difficult to generalize the or to classify the waste industrial wastewater, because due to product by product, it will the process is vary. So there is a different kind of the need which are required at the different stages of the every product manufacturing or every product development. So from the process is varying, so that the pollutants are available in the variety of the nature for the industry. So in the table, it is also seen that there are two ways in which the pollutant could reach the receiving body: the point source pollution and the diffuse pollution. So what is a point source pollution? In point source pollution, the pollutants reach the water body in points concentrated in the space. Usually the discharge of a domestic and industrial wastewater generates a point source pollution, since the discharge are through outfalls. So in the point source pollution, that due to the outfalls, the the contaminated water are reaching the surface body, and it will be get polluted due to that phenomena. So in the diffuse pollution, the pollutants enter the water body distributed at the various location along its length. This is the typical case of the storm water drainage, either in the rural area or in the urban area. So in the diffuse pollution, when the water are run off from with the help of the surface or with the help of the gravity, it will contaminate or it will collect the residual pollutants which are available at the different kind of the surfaces. So in the diffuse pollution, the main reason of the diffuse pollution is the storm water drainage, and there are the high chances of the pollution occur due to the storm water drainage. So there is a different two types of this point source pollution. Different types of the pollution. The one is a point source pollution, and the second is a diffuse pollution. Okay, so in the next chapter, the wastewater characteristic. Okay, so in the wastewater sewerage, there are the three methods: the collection, the treatment, and the disposal. So the collection, we can say that from the domestic uses or the for the industrial area, we collect the water sewage. Okay, so wastewater sewerage are collected from that particular location. There are the different kinds of the methodologies which are used for the collection of the water sewage. After the collection stage, there are the second, the treatment phase. In the treatment phase, in the treatment phase, we can say that there are the different kind of the aerobic and anaerobic processes are going to take for place to reduce the contamination level of the sewage. And after completion or after the treating the particular water, the third and the last stage is a disposal. Either it is a disposed in the land, or we can say that if we can reduce the contamination at a greater efficiency, so we can use that particular treated water in the day-to-day life, like not for the drinking purposes but for the cleaning and another purposes. So the wastewater sewage is accompanied by the following main alternatives. First is the off-site sewage, and second is the on-site sewage. So in the off-site sewage, there are the two types: the separate sewage system and the combined sewage system. So what is a combined and what is a separate system? We can see in this chapter. In the various countries, a separate sewage system is adopted, which separates storm water from the sewage, both being transported by the independent pipeline system. Okay. So in the various countries, the stormwater drainage as well as the sewage drainage are different. So it can be transported independently with the help of the pipeline. In this case, in principle, stormwater does not contribute to the wastewater treatment plant. In other countries, however, combined sewerage system is adopted, which directs sewage and the stormwater together into the same system. In this case, the pipeline have a larger diameter to transport not only the sewage flow but mainly the rainwater, and the design of the wastewater treatment plant has to take into consideration the corresponding fraction of rainwater that is allowed to enter the treatment works. In countries with a warm climate, during the dry season, sewage flows slowly in the large diameter pipes, leading to a long retention time, which allow decomposition and the generation of the malodor. In this book, focus is given to the separate sewage system, analyzing only the three components is listed above. However, the principle of the design of a combined sewage system based on the dry weather flow are the same. So, in the warm climatic countries like India, if we design the combined sewage system which contain the stormwater as well as the sewage water, so in that particular warm climate or in the summer season, the water is deposited in that particular larger diameter pipes, and due to that deposition, the generation of the malodors and the famines and the mosquitoes are going to take place, or the fall order are going to take place. So in the warm climate like India, there are the different kind of the facilities or the separate kind of the facilities are going to take place, that one pipeline is contain the storm water and the other pipeline is contain the domestic as well as the industrial wastewater. So this is kind of the figure that shows the on-site sewerage and the off-site sewerage. So in any urban areas, we generally seen that the off-site sewerage, which having a which having a large diameter of the pipe, which contain the which contain the sewerage waste from the domestic houses of the individuals and collected and transported to the wastewater treatment plant. Similarly, on the offsite collection system and does not cover the on-site system. These are of great importance and in many cases the best alternative in the various regions, being more applicable in the location with a low population density like the rural areas. Urban wastewater that flows in the offsite sewage system and contribute to the wastewater treatment plant is originated from the following three main sources. The first was a domestic sewage, including the residence, institutes, and the commerce, infiltration, and the industrial influence, various origins and the types of the industries. For the characterization of the both quantity and the quality of the influent to the WWTP wastewater treatment plant, it is necessary to separately analyze each of these three items. So we can prioritize that what kind of the pollutants are available in the domestic, in the infiltration, and in the industry. So just take a 1 minute break, and after that we will continue with the domestic wastewater. So just 1 or 2 minute break that we going to take place. Okay, so we're starting the domestic wastewater flow. Okay, so the preliminaries, the concept of domestic flow encompasses the sewage originating from homes as well as the commercial activities and institutions that are normally components of the locality. More expressive values are originating from the significant point sources must be computed separately and added to the global value. Normally, domestic sewage flow is calculated based on the water consumption in the respective locality. The water consumption is usually calculated as a function of the design population and of a value attributed for the average daily per capita water consumption. It is important to observe that for the design and operation of the sewage treatment works, it is not sufficient to consider only the average flow. It is also necessary to quantify the minimum and the maximum flow rate because of the hydraulic and the process reasons. So in the preliminaries, we are talking about the domestic pollutants or the domestic wastewater pollutants. So there are the different kind of the attributes which are going to take place, for the domestic purposes, what are the population ranges are available in that particular regions, and what are the average daily per capita water consumption of that population. And with the help of this data, we observe or we interpret that the what is the future forecasting of that particular, and how it will be going to affect our existing the water facilities. So it is important to observe that for the design and operation of the sewage treatment work, it is not sufficient to consider only the average flow. It is also necessary to quantify the minimum and the maximum flow rate because of the hydraulic and the processes reason. So in the next topic, the population forecasting, the population that contributes to the treatment plant is that situated inside the design area served by the sewerage system. However, the design population is only a certain fraction of the total population in this area, because maybe not all the population is connected to the sewerage system. The ratio is called the coverage index. This index can be determined or estimated, such as to allow the calculation of the design flow. In the final years of the planning horizon, it is expected that the coverage will be close to 100, reflecting the improvement and expansion of the collection network. The coverage index as a function is the following aspect. The first is a physical, geographical, and the topographical condition of the locality. It is not always possible to serve all the household with the sewerage system. Those not served must adopt other solution beside the offsite waterborne sewerage system. So we can say that in any region, when we are going to plan when we are going to plan a new kind of the sewerage system network, or we have to improvise our existing sewerage system. So with the help of the population forecasting methods, we can easily distinguish or easily characterize the different kind of the population increasing in the step by step, so that we can also find out that what kind of the processes or what kind of the improvements are going to take further in the various processes, and how we are closing to reach our aim. So in the final year of the planning, when we collect the various data from the various ULBs, urban local bodies, so after collecting and the interpreting the data, we have to reach the coverage will be close to the 100%, reflecting the improvement and the expansion of the collection network. The coverage index is going to depend on the variety of the features or the variety of the functions. Like the first is a physical, geographical, or the topographical condition of the locality. So it is not always possible to serve all the household with the sewerage system. Those not served must adopt other solution. So we can say that we cannot provide each and every household or each and every individual the dedicated or the efficient sewerage system. So the people or the particular area which are not served with the holistic connection network of the sewerage system, so there are the kind of the different alternative solution are going to take place for the sewerage systems or sewerage disposal or sewerage collection, we can say that. The second is the adhesion index. In this is the ratio between the population actually connected to the system and the population potentially served by the sewerage system in the streets. So adhesion index is going to take place when or the adhesion index is defined as the population actually connected to the system, actually connected with the collection system as to the required population served with that particular system. So this is called the adhesion index. In some communities, it is compulsory to connect to the collection system in case it passes in front of the house. In other community, this is optional. So this is the adhesion index. The next is the implementation stages of the sewerage system. In the initial operating years of the wastewater treatment plant, may not all the design, collection, and the transport system has been actually installed, and this affect the initial flow. For the design of the sewage treatment work, it is necessary to know the final population, as well as the initial population and its evolution with the time, in order to allow the definition of the implementation stages. So these particular population forecasting methods, there are the different kinds of the method, that the linear growth, geometric growth, multiplicative regression growth, and the decreasing growth rate. Okay. uh, and the logistic growth. Okay, so this kind of the methodologies which are using for obtaining the future population forecasting, and that in the particular region, that how many household or how many people are residing in the particular area for that now and in the next 5 or next 10 or next 25 years. So this is the different kind of the methodologies which are going to take further the linear or arithmetic growth. If you are using a Atul book, so this is called arithmetic growth, geometric growth, multiplicative regression, decreasing growth rate, logistic, graphical comparison between the similar communities, method of ratio and the correlation, and the prediction based on employment forecasting and the other utility forecasting. So table shows the main characteristic of the various method. All the method presented in the table can also be solved through the statistical regression analysis. Either it is a linear or a non-linear. So in the regression, like I can say that the regression analysis is a vast area that if you are talking about any kind of the statistical model, each and every model are equated with the help of the regression analysis. Either it is a water treatment connection system, either we can say that the urban transportation system, either we can say that it is a traffic facility, or any kind of the facility which are going to take equated with the help of the regression analysis. Either it is linear or a non-linear. Okay, so linear means that it is a kind of a uniformity are going to take in our data set, but we can say that the linear kind of the linear data set are least available for any kind of the facility, because we know that there is a randomness in each and every data set. The non-linear regression analysis are much more helpful rather than the linear regression analysis. Such methods are found in a many commercially available computer programs. Wherever possible, it is always based to adopt a regression analysis that allows the incorporation of the largest historical data series instead of 2 or 3 points, such as the algebraic method presented in the table. The result of the population forecast must be coherent with the population density in the area under analysis. The population density data are also useful in the computation of flow and loads resulting from a certain area or a basin within the town. When making a population forecasting, the following points must be taken into consideration. The population studies are normally very complex. All the variables that could interact in the specific locality under the study must be analyzed. Unexpected events can still occur, which can completely change the predicted trajectory of the population growth. This emphasizes the need to establish a realistic value for the planning horizon and for the implementation stages of the wastewater treatment plan. The mathematical sophistication associated with the determination of the coefficient of some forecast equations loses its meaning if it's not based on the parallel information, often non-quantifiable, such as a social, economical, and the geographical and the historical aspect. The common sense of the analyst is very important in the choice of the forecast and in the interpretation of the result. Even though the choice of the method is based on the best fit with the census data, the extrapolation of the curve require the perception and the caution. So there are the different kind of the population forecasting method which we gonna take a little discussion on that how it will be gonna work and what kind of the data sets are required. So the first one is a graphical comparison. The method involves the graphical fitting of the past population under study. The population data or other similar but larger towns are plotted in the manner that the curve coincide at the current values of the population of the town under study. This curve are used as a reference for the forecast of the town under study. So in this method, the past population data are fitted in the form of the graphical pattern. The population data of the other similar but a larger town are plotted in a manner like let's take an example. We have to develop a kind of the wastewater treatment plant for the Vadodara city, like we are talking about that with the help of the graphical comparison. So for that study, we take two or more than two cities which are larger than our study city or the study area. So the population graph are going to take place and which are fitted in the graphical format in the following sheet. And with the help of this graphical comparison or graphical representation, we can surely say that if this kind of the facilities are going to take place or are available in the larger town, so this kind of the facility are also effectively used or effectively implemented for that particular our study area. But there are the different kind of the limitations are available, that we have said that the population forecasting or the growth of the population are not linear in any nature. So there are the different kinds of the parameters, like the social, economical, culture, as any other financial, economical, this kind of the parameters are going to largely influence the increase or growth of the population in that particular area. So when we are comparing one data set to another data set, or we are comparing the larger town data set to our study area data set, so we surely get a reference point or a reference information about that. But for the finalizing or for the planning phase, the graphical comparison method is not suitably for that kind of, because there are the high chances of the fluctuation of the resulting for the one town and for the other another town. Okay, so this is called the graphical comparison. The second is a ratio and the correlation. It is assumed that the town population follows the same trend of the region in which it is inserted. Based on the census record, the ratio town population or the region population is calculated and the projected for the future years. The town population is obtained from the population forecast for the region and the calculated ratio. So next is a forecast of employment and the utility services. The population is estimated using a job prediction based on the past population data and the people employed. The job population ratio is calculated and the projected for the future years. The town population is calculated for the forecast of the number of jobs in the town. The procedures is similar to the ratio method. The same methodology can be adopted from the forecast of the utility services such as electricity, water, telephone, etc. The service utility companies normally undertake the studies of forecast and the expansion of the service with relative reliability. So this is a typical population density as a function of a land use. So this is not mm, useful. Okay, so our next topic is the average water consumption. As mentioned, the domestic water flow is a function of a water consumption. Typical values of per capita water consumption for population provided with the household water connection are presented in the table. These values can vary from the locality to locality. Table present various factors that influence water consumption. The data listed are simply typical average values being naturally subjected to all the variability resulting from the factors, like settlement with the population range is less than 5,000, so the per capita water consumption is 90 to 140. So for the India, our daily population or uh, per capita water consumption is 135 liter per inhabitants. Okay, so on an average Indian, you consume 135 liters for the day for the drinking, bathing, cleaning, and each and every thing. Okay, so rather than the, if we are talking about the different countries or the different countries patterns, that USA, the person or for average individual person in the USA, the per capita consumption is residing 350 to 450 liter per capita, liter per inhabitants per day. So for the Indian individual, our water consumption ratio is much lower than the another developed countries of the world. So the factors that influence the water consumption, the first is the water availability. In the location of water shortage, the consumption tend to be less. The second is the climate. Warmer climate induce a greater water consumption. Community size. Large cities generally present a larger per capita water consumption to for account for storage, strong commercial and institutional activities. Economic level of the community. A higher economic level is associated with a higher water consumption. Level of industrialized location present a higher consumption. Metering of household consumption, metering in inhabitants greater consumption. Water cost, a higher cost reduced consumption. Water pressure, high pressure in the distribution system induce great use and the wastage. And the system losses, loss in the water distribution network imply the necessity of the greater water production. So this is the different influencing factor. So for the G2 examination, this kind of the question are going to take place, like what is the water consumption, and what is the influencing factor that which affect the water consumption of a particular region for the individuals or for the inhabitants. So this is the kind of the graph which going to take place. Like this graph shows that the per capita municipal income into per capita water consumption. So the per capita income is high, there are the chances of the water consumption is also high. The next topic is the average sewage flow. In general, the production of the sewage correspond approximately to the water consumption. However, the fraction of the sewage that enter the sewage system can be different due to the fact that the part of the water consumed could be incorporated into the stormwater system or infiltrate. Other influencing factor in a separate sewage system are clandestine sewage connection to the stormwater system, clandestine connection of stormwater into the separate sewage system, and the infiltration. The last point is covered separately in the section. The fraction of the supplied water. The fraction of the supplied water that enters the sewage system in form of the sewage is called the return coefficient. Typical values vary between 60% and 100%, and the value of 80% is usually adopted. So this is called the typical water consumption in the some commercial establishment like airport accommodation, bar, cinema, office, hotel. So this is a kind of the factual data which are not going to remember. The average domestic sewage flow calculation is given by QDAV is equal to population into liter per capita demand into R. So what is R? R is a return factor, return coefficient divided by 100 meter cube per day. It is important to notice that the water flow to be considered in the flow is the flow actually consumed and not the flow produced by the water treatment work. The water flow produced is higher than the consumed due to the unaccounted water losses in the distribution system, which can vary typically from 20 to 50%. Thus, in the locality where the loss is 30%, for each 100 meter cube of water produced, 30 meter cube are unaccounted for and only 70 meter cube are consumed. On this 70 meter cube, around 80% returned in the form of the sewage to the sewerage system. The next one is a flow variation, maximum and minimum flow. Water consumption and wastewater generation in a locality vary throughout the day, during the week, and throughout the year. Figure presents the typical hourly influent flow rate variation in the wastewater treatment plant. Two main peaks can be observed: a peak at the beginning of the morning and the peak at the beginning of the evening. More pronounced and the more distributed. The average daily flow corresponds to the line that separate equal areas below and above the line. So this is called hours of the day, and there is a flow of the water. The following coefficients are frequently used to allow the estimation of the minimum and the maximum water flow. K1 is equal to 1.2 peak coefficient for the day with the highest water consumption. K2 is 1.5 peak coefficient for the R with the highest water consumption, and K3 is 0.5 reduction coefficient for the R with the lowest water consumption. So this is kind of the equation are going to take place, like Q maximum is a 1.8, Q average, like what is the water flow average for that particular day, week, R, day, week, and the year. It is possible to carry out a flow measurement to establish the real flow variation. The actual data should be used in the design. The coefficient K1, K2, and the K3 are generalized, that probably not allowing the accurate reproduction of the flow variation in the locality under analysis. Over or underestimate values affect directly the technical and the economical performance of the sewage work design. When considering hourly variation of the wastewater flow, it should be taken into consideration that the fluctuation are absorbed and reduced in the amplitude along the sewage system. It is easy to understand that the larger the network, the lower are the chances of the peak flows to overlap simultaneously in the work entrance. Thus, the residence time in the sewage system has a large influence on the absorption of the peak flows based on on this concept, some authors have developed formulas correlating the coefficient of the variation with the population or with the average flow. As an illustration, the following table represents the calculated coefficient for the different population. It can be observed that even the product of the coefficient K1 and K2 are utilized for water supply, and the frequently adopted as 1.8 could be induced an underestimate ratio Q max by Q average for a wide population range. So the next topic is infiltration flow. So we discuss this topic in the very next lecture. Okay, so see you in the next lecture. Thank you.